Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahka bin Muhammad Zahra. My matrix number is 13DK823F1003. Today I'm going to be doing a presentation in DCC40152 Water Supply and Wastewater Engineering. My lecturer's name is Puan Rahayu binti Anan. So, as for the introduction and problem statement, firstly, explain the importance of treating hospital wastewater, focusing on the potential risk of untreated discharge to public health and the environment. Okay, firstly, for the first point, hospital wastewater has dangerous bacteria, viruses, and chemicals. If not treated, it can make people sick and contaminate drinking water. Drinking water. Treating the water helps keep everyone safe. Okay, next, this wastewater can pollute rivers, lakes, and soils. It can kill fish and harm plants and animals. Treating it helps protect the environment. Clean water is important for everyone. Treating hospital wastewater helps us keep our water sources safe and healthy for future generations. Okay, next, highlight how hospital water contributes to achieving specific SDGs. Number one, by cleaning hospital water, we remove harmful germs and chemicals. This protects people from diseases and helps everyone live healthier lives. Okay. And secondly, hospital wastewater treatments keeps rivers, lakes, and groundwater clean. It also improves sanitation by stopping the spread of infection through water. Okay, next I'm going to explain about my illustrated process plan. So for the preliminary treatment, its purpose is to remove large solids and debris. Okay. In this stage, screens and grid chambers are used to trap big particles like tissues, plastics, or gloves. It protects the next stages from damages and clogs. Okay, secondly, primary treatment. Its purpose is to settle out suspended solids. The water is placed in a large tank so that heavier particles can settle at the bottom as sludge. Oil and grease float to the top and are skimmed off. This stage removes about 50 to 60% of suspended solids. Secondary treatment. Its purpose is to remove dissolved and organic matter. This is a biological treatment stage. Microorganisms are added to the water to break down organic waste like blood, body fluids, and drug residues. Techniques like activated sludge, trickling filters, or membrane bioreactors (MBR) are used. Okay, finally, tertiary treatment. Its purpose is final purification. This advanced stage removes leftover contaminants, especially chemicals, nutrients, and pathogens. Methods may include chlorination or UV disinfection, filtration to remove fine particles, and activated carbon to remove drug residues. So for the alternative solutions, we have number one, advanced oxidation processes. Um, it breaks down persistent organic pollutants, including pharmaceuticals and antibiotics, which are common in hospital wastewater. It works through highly reactive hydroxyl radicals that degrade complex compounds, and it reduces toxic load without producing sludge. Secondly, we have anaerobic membrane bioreactor. It generates biogas or methane, which can be used as energy. It's excellent at treating high-strength organic wastewater like that from hospitals. The energy recovery potential offsets the operational costs. So for the justifications for these two solutions, the justifications are for advanced oxidation processes, AOP such as UV slash H2O or ozone can achieve up to 95 or to 99% removal of pharmaceutical residues, endocrine disruptors, and resistance pathogen. As for the SDG alignment, it's SDG 6.3, improve water quality by drastically reducing contaminants before discharge. Secondly, for anaerobic membrane bioreactor, it, dem- uh, it demonstrates COD, chemical oxygen demand, that shows removal efficiencies of over 90% and biogas production up to 0.35 meter cubic. COD remove for the SDG alignment. SDG 6, clean water and sanitation. It meets discharge standards and enhance reuses potential. So for the discussion as SDG alignment, number one, environmental impact, SDG 14, life below water. The benefits are the proposed technologies ensure the proper removal of harmful pharmaceuticals, pathogens, and organic pollutants from hospital effluent, significantly reducing the risk of contaminating aquatic ecosystems. For the impact, it protects marine biodiversity by preventing eutrophication, antibiotic resistance in aquatic fowl, and destruction of hormonal system in fish and other species. As for the alignment, it supports SDG target 14.1 by 2025, removing and prevent and significantly reduce marine pollution of all kinds, particularly from land-based activities. Secondly, social impact. SDG3. The benefits are removes up to 99% of disease-causing pathogens and drug residues. Reducing public health risks and such as waterborne disease, antibiotic resistance, and exposure to toxic substances. The impact is it safeguards health of hospital staff, patients, nearby communities, and downstream users of water sources. For the alignment, it supports SDG target 3.9 substantially reduces the number of deaths and illnesses from hazardous chemicals and air, water, and soil pollution. And lastly, number three, economic impact. The benefits are it creates green jobs in the installation, operation, and maintenance of AOPs and AMBR systems. It reduces long-term costs by improving energy efficiency and enabling biogas recovery through AMBR, which can offset operational expenses. For the impact, it encourages sustainable industrial growth and technological innovation in the water treatment sector. As for the alignment, it supports SDG target 8.4 by and improve progressively through 2030 global resource efficiency in consumption and production. That is all. Thank you.